Here is the answer for the day 4 bell work. Calculate the energy of a quantum of radiation that has this frequency. Show the formula, substitutions, and answer with the label. Well, here's the formula that you use whenever a problem involves energy and frequency. The letter E represents energy. The letter H is Planck's constant. And this one here was the Greek letter nu. It was frequency. The problem asks us to find energy, and the variable E is already alone on one side of the equation, so we don't have to transform this equation like we did in the day 3 bell work. We're ready to make our substitutions. E equals. Now let's replace the letter H with the number that you always put in for H, Planck's constant. It is 6.626 times 10 to the negative 34 power joule seconds. Now the formula says to multiply by nu. So we're going to times by the frequency, which is given in the problem. 3.80 times 10 to the 12th power hertz. Like the other day, the symbol hertz can also be written as per second. Now the reason I write it as per second instead of writing HZ for hertz is so that some canceling of units happens. This S for seconds will cross cancel out the per S. And notice the unit left is a capital J. It stands for the word joules, and it's a unit of energy, which is what we were asked to figure out. The only thing left to do is to type this in the calculator. We're just going to type straight across. 6.626 times 10 to this exponent times 3.80 times 10 to this exponent, and push enter when you get to the end. The result on the calculator screen is 2.51788 times 10 to the negative 21 power, and the label is joules. Now let's think about the rounding. This was a multiplication problem, so we need to look at the significant figures in the numbers in the math problem. This one has 1, 2, 3, 4 significant figures. Over here there's 1, 2, 3, and that's going to limit our answer to have 3 significant figures. So we'll round this to 2.52 times 10 to the negative 21st power joules.